Hello everyone. Today we shall discuss about a new chapter, and that is gravitation. You see what are the various factors of gravitation, and we learn all the chapters of gravitation, and you see what are the various factors we want to learn in gravitation, and that are going to discuss with you. First of all, we'll learn what is the meaning of gravitation and what are the basic factors that we're going to deal with these things. First of all, learn that what is the meaning of gravitation. After that, we'll learn how the gravitation differs from other things. First of all, what we learn about that in gravitation, that every material object has a tendency to be attracted towards the earth. The tendency of an object is governed by few laws, namely Kepler's laws and gravitational law. First of all, we learn about the universal law of gravitation, and you see how we learn about the universal law of gravitation. In universal law of gravitation, you will find that the first of one we will deal with is universal law of gravitation. You see here we are finding the universal law of gravitation first, and we learn the various important things in universal law of gravitation. You see here these are the various factors we are going to deal with it. First of all, we learn that universal law of gravitation. What are the universal law of gravitation that I am going to discuss with you? This is universal law of gravitation. Universal law of gravitation. What is the universal law of gravitation? First of all, we learn about universal law of gravitation. Universal law of gravitation. First of all, we learn some laws. The first one is universal law of gravitation. What it says that? It states that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. What is the meaning? Suppose there are two objects. This is mass m1 and these are point masses, and we have already discussed about what is the meaning of point masses. These are the centers, and these point masses are separated by distance, suppose r, small r. And what it says that the gravitational force between two point masses m1 and m2 separated by distance r is given by, number one, the gravitational force. The gravitational force, the gravitational force if between two point masses, between two point masses separated by distance, separated by distance small r, distance small r apart is given by, what is that? It says that this states that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses, and this force is directly proportional to the product, means multiplication, m1 into mt. This is equation 1. And we find the other thing that and inversely proportional to the square of the distance between them. And f is inversely proportional to the square of the distance between them, 1 by r square. This is equation 2. If you combine equation 1 and equation 2, you see, if we combine equation 1 and equation 2, we get what we are getting. You see here, we are getting what we will get. If we combine equation 1 and equation 2, we will get that f is directly proportional to m1 into m2 by r square. Now, since this is proportional, we know that there should be a proportionality constant between them, and that can be written in this way, that f is equal to, there is a constant of proportionality, and the constant of proportionality can be written in this way, capital G into m1 into m2 by r square, where G is a proportionality constant, and this capital G is known as universal gravitational constant. This is known as universal gravitational constant. Universal gravitational constant, and it has a fixed value. The capital G has a fixed value. Since it is a constant, the value can be written as 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the value of capital G. So you find that the value of G is this way, right? And the value of G is 6.6 10 minus 11 Newton meter square per kg square. And if we want to write the force of gravitational force in vector form, we can write it also in vector form also. How to write in vector form? In vector form, it can be written as F is equal to, this will be expressed as minus. What is minus? Because gravitational force is an attractive force, so it is minus. F equal to minus capital G into m1 into m2 by r square and r unit vector. You know that r unit vector can be defined as r vector by r modulus of r. That it can be written in this way also, that is capital G into m1 into m2 by r cube and r vector. This can be written in this way also, that capital minus G m1 m2 by r cube and r vector. What is the r? R is a unit vector from m1 to m2. Now r can be written as r is the displacement vector, and displacement vector is written as r2 minus r1, r2 minus r1 vector. This is the r is the displacement vector, right? So we learn all these properties. So this is universal law of gravitation, and what we find that the value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now we learn other things also, that is, what are the various characteristics of gravitational force. Now we learn the various characteristics of gravitational force. You see here the various characteristics of gravitational force are, now we are giving number 2, that is this one. You see here, what are the various characteristics of gravitational force? The various characteristics. Now we learn about the characteristics of gravitational force. Characteristics of the gravitational force of the gravitational force. Characteristics of the gravitational force. We'll see what are the various characteristics of gravitational force. See here, number one. Now one is, these are the few characteristics of gravitational force. The gravitational force is attractive in nature and directed along the line joining the two-point masses, that is capital F is along minus r. The gravitational force, these are the few characteristics. The gravitational force, the gravitational force, the gravitational force is attractive in nature. Is attractive. The gravitational force is attractive in nature. The gravitational force is attractive in nature and directed along the line, joining the point masses, joining the point masses, that is the force F, that is the force F is along minus r vector. Why it is minus? Because this is attractive in nature. I already found that capital F can be written as minus g into m1 into m2 by r cube and r vector. And r vector can be, this is the displacement vector, can be written as r2 vector minus r1 vector. And we have already learned that the gravitational force is attractive in nature. And number two, this is the characteristic number two. The direction of gravitational force on m1 due to m2 is along r. So Newton's third law is up. This force is of course minus F. So we can say the direction of gravitational force, the direction of gravitational force on m1 due to m2 is along r vector. So by Newton's third law, this force is of course, minus F. Right? We've already learned these things. And in number three point is, if these are the few characteristics, if 1, 2 is the gravitational force, force on body 1 due to body 2 and F21 and F21 is the gravitational force, on body 2 due to body 1 due to body 1 then they are related, then they are related as if 1 and 2 is equal to minus if 2 and 1. If 1 2 is the gravitational, if F12 is the gravitational force on body 1 due to body M2 and F21 is the gravitational force on body 2 due to body 1, then they are related as F12 is equal to minus F21. And the fourth one is very much important, is that gravitational force is a central force. Gravitational is a central force. Gravitational force is a central force. This is one of the characteristics of gravitational force. Number 4, you can say, number 5, the gravitational force is a conservative force also. Gravitational force, gravitational force is a conservative force. Conservative. You have to know what is the meaning of conservative force. Conservative force means it doesn't depend on path. The work done by gravitational force on a particle is independent of path described by the particle. Therefore, the work done by gravitational force, work done by gravitational, work done by gravitational force, work done by gravitational force on a particle is independent of the path, is independent of the path described by the particle, described by the particle. Gravitational force is a conservative force. The work done by gravitational force on a particle is independent of the path described by the particle. It depends only on the initial and final position. It depends only on initial and final position, initial and final position, and final position. And we can say the work done in a closed path is always 0. And you can say the work done on a closed path is 0. So we can write in this way that work done in a closed path W is equal to 0. These are the few of the characteristics of gravitational force. Besides that, there are other factors also. Number 6, notice the characteristic number 6. Number 6 is the universal law. The universal law of gravitation. Universal law of gravitation refers to the point masses refers to the point masses, whereas we deal with extended objects, whereas we deal with the extended objects which have finite size, which have finite size. So you can see here that the universal law of gravitation refers to the point masses, whereas we deal with extended objects which have finite size. Now these are the few characteristics of gravitational force. Number 7, this is the characteristics number 7. If you have a collection of point masses, if we have collection of point masses, collection of point masses, the force on any one of them if you have collection of point masses, the force on any one of them is the vector sum of the gravitational forces of the gravitational forces exerted by the other point masses as shown below. Now suppose here that we have taken 3, 1. Suppose that we have taken 3 masses, that is, we have taken masses 1, this is M1, this is M2, and this is M3, and this is we have taken M4. Now you can see, if we join all these join this one, so they are in straight line. Not in this way, but it will be in a straight line. I already told you that they are along a straight line. So we can write here in this way also. That is, this one is M1, M2 and M3. And we join the lining, you will get the resultant as the vector sum of all these things. The total force on M1 is this one, you can write here as R vector. This is the direction. If you see this one, so you can write here as that if that R vector, R unit vector 1 to 3 can be written as minus R vector 3 on 1, right? And this R unit can be written as R vector 1 and 2, 1 on 2 is equal to minus R vector 2 on 1. And here can be also written as R14, written as R vector, R unit vector 4 on 1, but this will be minus. So the total force on M1, so the total force on M1 will be capital F1, the force is equal to capital G M2 to M1 R 21 whole square and R unit vector 211 R unit vector 211 plus capital G, that is M2 M1. This is between M2 and M1, and this is between M3 and M1. M3 and M1. It is capital G M3 into M1 by R 31 whole square R unit vector 3 and 1, and it will also written as plus, if it is M4, between M4 and M1, capital G into M4 M1 R41 whole square and R41 unit vector. This is the sum. So you can find here that if we have collection of point masses, the force on any one of them is the vector sum of the gravitational forces exerted by the other point masses as shown below. In this way we got the result. So if we add all the vectors, we will get the force on them. In this way you can find the vector sum. So these are the various characteristics of gravitational force. Not only that, there are other characteristics also. Now question number 8 number characteristics. What are the 8? That is the force of attraction between a hollow spherical shell of uniform density and a point mass situated outside is as if the entire mass of the shell is concentrated at the center of the shell. The force of attraction, the force of attraction between a hollow spherical shell of uniform density, and a point masses and point mass situated outside is just as if the entire mass of the shell is concentrated at the center of the shell, So these are the few characteristics of gravitational force. The force of attraction between a hollow spherical shell of uniform density and point mass situated outside is just as if the The entire mass of the cell is concentrated at the center of the cell. And the last one, that is 9, this is the last characteristics of gravitational force. The force of attraction due to hollow spherical shell of uniform density on a point mass situated inside it is 0. The force of attraction, the force of attraction, the force of attraction due to a hollow spherical shell, hollow spherical shell, spherical shell. The force of attraction due to a hollow spherical shell of uniform density, The force of attraction due to a hollow spherical shell of uniform density on a point mass, situated inside it is 0. These are the few characteristics of the gravitational forces. So what we learned here, that the universal law of gravitation. We state that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And these are the few characteristics of gravitational force. The most important characteristics of gravitational force are that the gravitational force is a central force. The gravitational force is a central force. The gravitational force is a central force. You can see here that we have learned all these factors, that is characteristics of gravitational force. What are these? You can see here that universal law of gravitation has few characteristics. The most important characteristics of gravitational force is that gravitational force is a central force. And number 2 is the gravitational force is a conservative force, and it is the weakest force in nature. And also number 10, we can say the gravitational force is the weakest force in nature. And number 10, we can say that the gravitational force is the weakest force. These are a few characteristics of gravitational force. Again, I am repeating once again the various characteristics of gravitational force. The gravitational force is attractive in nature and directed along the line joining the point masses. That is, the force F is along minus r vector. The direction of gravitational force on M1 due to M2 is along r vector. So by Newton's third law, this force is of course minus F. Third point is if F12 is the gravitational force on body 1 due to body 2, and F21 is the gravitational force on body 2 due to body 1, then they are related as F12 equal to minus F211. I already told you that according to Newton's third law of motion. And gravitational force is a central force. I already discussed about it. Not only that, gravitational force is a conservative force also. And gravitational force is the weakest force in nature. Therefore, the work done by gravitational force on a particle is independent of the path described by the particle. Since it is a conservative force, gravitational force is independent of the path, and it depends only on the initial and final positions of the body. And the total work done in the first path is also zero. I already told you that the work done in the first path is zero in conservative force. It is independent of the nature of the medium in which the point masses are present. And also we can say that number 11 characteristics is it is independent of the nature. It is independent. It is independent of the nature. Independent of the nature of the medium in which point masses point masses are present. Point masses are present. So you can see here that these are the few characteristics of gravitational force. And also it holds good for long distances like interplanetary distance, and also for short distances like interatomic distances. And also this is the number 12. This is also a characteristic of gravitational force. That is, it holds good. It holds good for long distances. For long distances like interplanetary distance, and also for short distances like interatomic distances, like interatomic distances. So these are the few characteristics of gravitational force. Not only that, it depends upon the initial and final positions of the particle. So the work done by gravity around a closed path is zero. The universal law of gravitation refers to the point masses, whereas we deal with extended objects which have finite size. If you have a collection of point masses, the force on any one of them is the vector sum of the gravitational force exerted by the other point masses. We have already shown this one. And the force of attraction between a hollow spherical shell of uniform density and a point mass situated outside is as if the entire mass of the shell is concentrated at the center of the shell. The force of attraction due to a hollow spherical shell of uniform density on a point mass situated inside it is zero. These are the few characteristics of gravitational force. So we have learned the first of all, the universal law of gravitation and the various characteristics of gravitational force. In the next session, we will learn about the various laws of Kepler's law. So, if you want to learn from us, then please download our app which is given in the description. There is an app link in the description you will find. From there you can download our app and we give online tuitions on those apps. And the name of the app is Pi Education. Thank you everybody for watching this video.